Thank you, Christian, and thank you and your team for putting this event on an ongoing basis. And I'm really honored to speak with you on this 8th annual Green Carbon webinar series. There's a lot of information that is going to be shared in this PowerPoint presentation, but I'm going to try to keep it succinct. So let's get started and go to slide 2. Hard-to-abate industries need to be tackled now to achieve climate restoration and climate repair. These sectors of industry are behind a curtain, but they make up more than 30% of the emissions that are causing climate change. They include mining and metal refining, which is the topic we're going to be discussing, long-haul transportation, and the building industries. Those 3 industries are hard to abate. They're not the only ones, but the reason I combine those 2 and others combine those 2 is because mining uses transportation, long-haul transportation to a large extent, and also building and construction is involved in those industries. Let's go to slide 3. So here's our overview. Today, we're going to be talking about the need for minerals to advance a circular economy. We're going to review mine remediation through reforestation. And then we're going to talk about the transition to mine remediation using biochar. Then we'll discuss heavy metals and arsenic as risk elements. And then I'll touch upon circular gold and silver mining projects that we're going to be deploying and implementing, and the 2 methodologies that we will be integrating: traditional mining processing and circular mining processing. And of course, everybody wants to know, how do you fund it and what is the return on investment? Back in March of 2020, with the shutdown of much of the world due to COVID-19, Angela Merkel, then the Chancellor of Germany, and by the way, Angela Merkel has a doctorate in quantum chemistry and is a practicing scientist. And her colleague, Ursula von der Leyen, the president of the European Commission, proposed a recovery similar to that of post-World War II Marshall Plan, which was then formerly known as the European Recovery Plan. The US-sponsored program was designed to rehabilitate the economies of 17 Western and Southern European countries in order to create stable conditions in which democratic institutions could survive and could withstand the Iron Curtain. That's what Churchill called it. In the original Marshall Plan, Secretary of State Marshall, not named after me, obviously named after him, advanced the idea of a European self-help program to be financed by the United States through U.S. savings bonds. It became the genesis of what is known today as the 24-nation European Union, and it was based upon traditional industrialization and the might that it brings and the wealth it brings. Back then, the victors were unaware that traditional industrialization would lead to today's climate crisis, today's anthropogenic, that is human-caused, climate change and impacts. Today, the EU recovery program that was premised back in 2020 of March is based on a circular economy approach in which there will be a transition towards zero waste. Today's waste will become the raw materials that abate climate change and damage and are financed through European Union climate bonds. Since March 2020, there have been over 2+ trillion euros in climate bonds issued in this endeavor. Now, of course, other elements have interfered, like the war in Ukraine and other political events, but it's still in process. So let's go to slide 4. Today's renewable technologies require minerals and metals. Without them, we can't build the electronic vehicles or the EV batteries or the blades for the wind programs that we're doing around the world. And we're beginning to see the sourcing and consumption of raw materials take on financial, political, and strategic imperatives. And in this slide, I underlined the most important element. 10% of the European Union's consumption of strategic raw materials should be mined in the EU. In addition, 15% of the Union's annual consumption of each critical raw material should come from recycling. That's the source of that is Euroactiv. And I also noticed that there are other publications like McKinsey have been quoting the same numbers. What we're seeing here is not just the EU's localization of its raw materials and its metals, but we're seeing it all over the world, including in the United States and North America and in China. Let's go to slide 5. Up until recently, mine remediation, for the most part, has taken place through what's known as reforestation. Reforestation will continue to play a role in mine remediation, and it will not go away. It's required. However, a transition has begun toward mine restoration through the use of a material known as biochar. Let's go to slide 6. So most of you attending this forum are familiar with what is biochar. However, for those watching today who are unfamiliar, biochar is a highly stable form of carbon that is produced by heating organic material in the absence of oxygen using low temperature pyrolysis. Now, there are other methods to create biochar, but that's the one that we believe is the most resilient and best and easily deployed. It can be used to remediate mines by filtering borehole water so that it can be recycled and reused in mining and operations. A lot of water is needed in mining. You cannot believe the amount of water that's used. It's tremendous. It can also be employed to restore soil to an environmentally sustainable condition at mining sites, as well as to sequester carbon. The difference of what we're doing here is taking depleted mines. Up until now, we've been dealing with depleted mines and mining properties, and I've been involved in a few of those. But now we're going to implement these practices that we're bringing to the table together with active mining properties. All right, slide 7, please. Biochar can be applied as an excellent tool for mining site remediation, as I said previously. For perspective, to give you a perspective on this, 1 sugar cube worth of high carbon biochar has the surface area of, in the United States, Giants Stadium in New Jersey, including all the seats, offices, locker rooms, parking structures in the field. This might be equivalent in the UK to Wembley Stadium in London or Camp Nou in Barcelona, Spain, for all you sports fans out there. The significance of adding biochar to a contaminated land and water is that it can work as a sorbent for solution phase metals. We've done this and we will do it again. As you can see from these 2 images on the screen here, biochar looks like a carbon sponge. Its superpower is that it is an adsorbent, and I state adsorbent, AD, not AB, not to be confused with absorption. Adsorption is the process in which atoms, ions, or molecules from a substance, which could be a gas, liquid, or dissolved solid, adhere to the surface of the adsorbent. Here, the adsorbent is a piece of char or made from some waste material, usually woody biomass or other organic material. And adsorption is a surface-based process where a film of adsorbent is created on the surface, while absorption involves the entire volume of the absorbing substance. Absorption is the process in which a fluid is dissolved by a liquid or a solid, just as when you drink water, that then brings oxygen to the bloodstream and nourishes our brains. Now I'm going to show the next few slides. Let's go to slide 8, Mark. Here are examples where biochar has been used in mine remediation. And when I'm showing you before and after images. So these have been studied since 2013 through 2015 by Andrew Harley, who's the mine director at SWCCA. And here you see a coal mine before and after with biochar. And you see a gold mine in Rio Grande, Texas, before and after with biochar. Mark, let's go to 9. So we also can deal with what are known as dispersed tailings. Tailings are one of the primary wastes that come out of the mining process. Tailings are usually composed of not only some of the metals that you're mining, but that cannot be extracted because they're commingled with metalloids like arsenic. Arsenic is heavily used especially in gold and silver mining, but other mining operations, and other chemicals that are used in the mining operation. And they're highly toxic, and they're usually left on the ground. Here you see the Waldorf mine in Colorado before biochar was used in the process of cleaning it up and after. Let's go to page slide 10, Mark. These are established processes for remediation as well as criteria for the use of biochar. There are a number of them, and this is a complex slide. So I'm going to make it simple like I did with the sugar cube and make it relatable to most people. I'm going to use an analogy, that of a patient in need of surgery. A surgeon, when he's going to perform surgery, needs to know the patient's condition, whether that surgeon will use an arthroscope or a scalpel or any other tool, and how the patient will respond to anesthesia. So just like the surgeon or in surgery, the mine operator needs to understand the type of mining operation, the site, its geography and geology, who may be the beneficial owners of that operation and benefit from the mine itself, and how it affects the local population. And when I say local population, I mean both human and other species. Let's go to slide 10. I mean 11, sorry, there we are. Excessive concentrations of heavy metals and arsenic, as we showed in the depleted mine area with the tailings. So excessive concentrations of heavy metals and arsenic can cause toxic response in plants, animals, and humans through direct or secondary exposure, resulting in unacceptable levels of environmental risk and health risks. Now, this threat can be turned into an opportunity by employing at industrial scale the use of biochars and our other complementary technologies. Let's go to slide 12. So what we're proposing and what we are going to be doing is a combination of circular gold and silver mining in Nevada. And we're going to be doing it in other areas, such as we've been approached by people in Africa and Canada as well, to bring our circular gold and silver mining project approach to the table. This involves traditional mining, and it involves our circular mining methodology. And of course, we need to get it funded, and we need to demonstrate a return on investment. Next slide, please. Now, there are many types of traditional mining operations. I personally have been involved in the remediation of some of these types of depleted mines. All the mine types can and should be included using a circular mining methodology. In Nevada, we'll be working on a placer mine, that's number 3, where you extract the minerals such as gold and platinum from alluvial deposits, which are deposits of minerals that have been washed down from mountains and deposited in rivers and other bodies of water. And throughout Nevada and California, that was the beginning of the gold rush in the 1840s, and it's still in existence today. Lots of placer mines in those geographies. The artisanal and small-scale mining that I highlighted in number 7 can be found in the rainforests of the Amazon and throughout Africa. These are very problematic because they cause untold harm in the environment, and they use the local population, and in our opinion should be addressed again with circular mining approach. This typical mine is typically done by individuals or small groups using simple tools and techniques to extract minerals from the earth. And it's informal and is not regulated at all. Like in the United States, mining is regulated, but still causes a lot of contamination and pollution. Let's go to slide 14. We deploy several technologies to clean up mining operations as they occur. The use of biochar and our complementary technologies can lead to local economic revitalization by creating job opportunities in the mining industry and by lowering operating costs by harvesting the metalloids, the arsenic, and the other chemicals from tailings for subsequent processing and what we call closed loop recycling. In other words, most people, when they're talking about recycling, they're talking about the end use products. Let's say from the mines you make electronic batteries, EV batteries, and you want to recycle those. And we definitely want to do that. And there's a process for that. But in the mining itself, we need to take the materials that we're using that are usually put into the tailings or into the water and recycle them and recover them, which we can do using especially 4 of our technologies, but we have other technologies as well. The basic technologies that we have is our pyrolysis systems that can take the syngas and convert it into electricity and run on through our Zajac engine, which is an ultra low emissions engine. And to give you a sense of the perspective on that, most engines are not hot wall reactors or cold wall reactors, and that's why you need a catalytic converter to run them to try to clean up the material, and you still have pollution. With the Zajac engine, we have ultra low emissions to 0 emissions. We put them on the back end of the pyrolysis systems, and they are able to generate the power that is required to bring the electricity to the location and to the people that are out there in the field. In addition, to clean up the water, we are processing through additional biochar filters, and there's different types of biochar filters that are required. We need certain biochar filters to remediate and extract the heavy metals, which can then be recycled, and also the NPK that is typically found in bioswales around properties. And then you need, then we oxygenate the water through our ultra nano bubble generator, and we can even make it potable by putting our EPA registered EnviroProtect antimicrobial into a sand filter. The complement of solutions completes the cyclical remediation at the end of the mine's life cycle. Typically, that's what we can do. What we're suggesting and what we are doing is we're going to implement this during the mining process itself. I also want to establish that when we do this, we incorporate the United Nations 17 Sustainable Development Goals and their 119 plus protocols so that we become a true proponent of equity, fairness, and wealth generation for both the mine owners as well as the local populations. Let's go to slide 15. Now, of course, the big question that everybody asks when we get involved in these things is, how do you fund this? So whether we finance our projects through royalty streaming revenues, and that's a new, royalty streaming has been around for a while, but it's taken off since the pandemic. And there's carbon royalty streaming, there's gold royalty streaming. It's a mechanism in which revenue, you're generating income through the revenue streaming, and you're also paying back any funds that you're putting into it. And also, of course, there's traditional project finance. For those who are financially astute, they know that major corporations like the big banks and the big investment banks provide traditional project finance. And of course, as I stated in the beginning of this presentation, there's the EU climate bond. And whether we finance our projects through any of these, the traditional project finance or royalty streaming, or the EU climate bond, we ensure that we always follow the EU climate bond taxonomies. Taxonomies are a set of rules, and these taxonomies are science-based, not just financially or politically based rules. That's really important because there's a big argument and discussion out there at all the COP conferences of how do we know that we're not going to have greenwashing in place. And I want to go to the next slide. So critical metals are in high demand. And what's important here is to meet these needs, we are ensuring that we can abate the danger to society while meeting the projected demand for critical metals, all the while restoring the soil and the water needed for mining and improving the air quality and the environment. Without mines, you can't get a circular mining a circular economy going in any capacity, whether it's electronic vehicle batteries or whether it's the blades from windmills or power mills, wind power, or other renewable technologies. We need metals. So there is a projected demand for growth. The mining industry contribution to GHG emissions, soil contamination, water pollution needs to be abated, and we have the ability to do that. The data is out there, and when I say the IPCC report in this slide, I'm not referring to the 600-page report. That's done by politicians. You always go to the science. There's a 3,300-page IPCC report that was issued in April of 2022, and was supported again by NASA studies in July of 2022 that said actually the IPCC report was under reporting the seriousness of the threat of GHG emissions around the world. So we need to abate this danger to society. Again, arsenic and the toxic chemicals can be reprocessed. They are known carcinogens, and we can bring this home to everybody. And this should be, in our opinion, the tip of the spear in the use of biochar and other remediation. Not to say that we don't use remediation for soil amendment for farmers or other uses. They all have to be used. We have to do it all together. We need all hands on deck. Mark, go to the last slide. So here's our contact information if you need it. In the chat, I already put my LinkedIn connection. In addition to that, there's my WhatsApp number. But if you need to contact me and don't know me, I'm not going to take a call. I get a lot of calls from a lot of spam. So I would prefer that you use WhatsApp to connect with me and send me a text. Once you text me and I know who you are, then we can create a connection. The last comment I have to make before I hand back to Christian is that we encourage everybody to be involved, whether on your own or together with us. So if you have the desire to be a part of this process, both financially or as a mining operator or as a mine owner or as a technology supplier, feel free to get in touch with us. Time is of the essence. We need all hands on deck. We welcome everybody. And Christian, I want to thank you for giving that my time to do this. And I hand it back to you for any questions, or we can go to the next presentation.
Thank you very much, Marshall, and also Mark for the assistance. So the floor is open to any questions. So either you write them into the chat or you unmute yourself. So there were already some questions in the chat. The first question, no, that's not a question. So Jan Mume was asking, thanks, Marshall. How do you recover the adsorbed metals from the spent biochar?
So that's a great question. And the secret sauce there, it's not a secret, is that what we do is we always ensure, by the way, in order to remediate a mining operation that has, let's say, $12.7 billion of gold and silver in the ground, and is usually identified through not only core drillings, but also through what's called NMR, nanomagnetic resonance. My analogy, again, I use a simple analogy. It's like going to the dentist and getting your teeth x-rayed so they see where the cavities are and where they need to drill, right? So that's what NMR is for mining operations. And by doing that, we know where the mining deposits are, and we can go straight to them. When we used biochar, we acquire these heavy metals in the biochar, and we need lots of biochar. I would say in a typical mining operation of about 12.7 billion over 20 years of extraction, or anywhere from 6 to 20 years, you need at least on an annual basis 2 million metric tons of biochar to help the remediation. But that's good news, because what do we do with the biochar? And that's the question. Once it has that material in it, we put it through our high process pyrolysis system, which can process 120 metric tons of this material a day, and it extracts and breaks down the tailings and the char itself, and we recover all the materials in a specific format, and that's the technology. We use pyrolysis and a few other technologies to do that. So hopefully that answers that. Go ahead. What's the next one?
So another one was if you can, I'm not sure if you can answer it, but what is the project's internal rate of return, or what's the range from a typical project?
Well, that is specific to the mining projects. So to give you an example, the ones in Nevada that we're approaching that have a valuation of about $12.7 billion over 20 years. So if you take 12.7 billion US dollars divided by 20 years, you know the amount of gold and this is gold and silver, but let's just say gold for the moment for simplicity's sake. So back in 2015, when we began this process, gold was going for $1,300 a troy ounce. Does anybody know what it is today? I'll just tell you. It's over $2,000 a troy ounce. And that's because of the war in Ukraine, but also without the war in Ukraine, it would be around $1,900 a troy ounce. And gold, unlike pork bellies, is a inelastic commodity, meaning elastic commodities like pork bellies or wheat. The more you grow, the lower the price per unit. Gold is not that way. Whether you buy 1 gram of gold or 1,000 grams of gold, it's $2,000 a gram. A troy ounce. It's an ounce. They're sold by ounces, not grams. So to give you a sense of return on investment, it's pretty significant. And that's another reason why this should be the tip of the spear, because it will help to pay for other projects that we're doing in soil remediation for farmers, and so because that's a biochar for that area is more like an elastic type price market than an inelastic like metals. Hopefully that answers that question.
Yes, I think so. There was a follow-up question on the first one. So if you need 2 million metric tons of biochar, so where do you get the amount of biomass from?
That's a great question, and I can give you an example of how we're doing it. We have our own technology, but we also acquire and create relationships with other biochar providers. The issue of biochar is that not all biochar is equal. It depends on the feedstock and what you're doing, but we have our framework, and we have great relationships so far with some of the top large biochar producers out in the marketplace, especially here in the United States. But we do have them in other parts of the world. We also form joint ventures, and that's why I said you can participate with us. If you have a waste facility, like we have several joint ventures in the United States as well as other countries where they have a high carbon char material. And what we do is we put our systems there, and the European Climate Bond pays for that, and it allows us to get a return on investment on that. But also we acquire char from others, because even if we build 48 of our Alpha 3 systems and deploy them around the world, it's not enough char to supply for these projects. We need all hands on deck. And the good news about that is we encourage our so-called competitors not to be competitors, to become collaborators with us in this process. We will give them the right price for their char, and they will benefit as well. And it'll help the communities that we're in.
Yeah, so if you need for biochar in Europe, go to our partners at Enchar.
Yes,
so
exactly.
We can
by the way, we want to thank Enchar for sponsoring this 8th annual webinar.
And you already touched at the next question. So what are the specs of biochar that you would need to remediate? Have you established a pricing level of delivered biochar? So I guess you have to put, again, this in the context of a specific operation. But any ranges you can, any trends you see?
I'm not sure I understand the question. What
are the specifications of the biochar that you would need to remediate?
Oh, okay, great. That's great. Okay, so yes, there are some general parameters. We have more specific parameters, and we work together with our partners that we're buying the biochar from to make sure that we meet those parameters. The way we do it is we characterize the char 3 times. The beginning, we take a sample, characterize it through either IBI or European standards, and then we do it again at before we ship the quantity, as we ship each batch of char that's going to go into the mining project, and then we also test it on site to make sure that it still meets that requirement. Because biochars can change over time, by the way, and due to shipping. But there are special shipping methodologies that we prefer as well. The other thing is the biochar that, in order to get the quality of the biochar, for mining properties, you need at least 80% carbon or above. For a soil amendment, you need a 60% or above. So if we're using biochar, let's say in a post-remediation area, like I showed you in those slides, where we are cleaning up the, once we cleaned up the tailings off the ground and we want to recover the soil, we need probably 60% carbon or above, and it needs to be a formulated char for that particular soil property. You just don't put biochar into the ground. A lot of people think that's what they do, and they do it, and then they find out that, as we understood under the cost action of biochar with the UK Biochar Center many years ago, that when you do that, the longitudinal studies show that you actually will deplete the soils. So you don't want to do that. It has to be mixed. And so 60% carbon char is great for that phase of the property near the end. But during the mining process, we prefer 80% carbon and above, and we have our specifications on how to do that.
And the last very quick answer before we jump to the second presentation. Any price range you can tell the audience, because that was popping up several times for
Sure.
that you...
Sure. So for mining operations, what we do is, excuse me, right, a little bit of a cough there. Hopefully it's not COVID, right? So seriously, the pricing depends on the location, locale, and shipping, and a few other aspects. But generally speaking, right now, we're looking to obtain the elemental char that Mark and I call, and the rest of our team call. We call the char that comes out of the machine, out of the pyrolysis machine, elemental char. And if it needs to be formulated, we call it formulated char. Obviously, if it's organic, then it's biochar. In other words, if the source of the material is organic. And most people can't do this, but we can take MSW and process that and create it in elemental char, but you would never use it in mining properties. It's used for other purposes. And just so you know, to give you a sense of pricing, pricing for biochar in a short ton in the United States is usually going for around $120 a short ton. We're at a higher rate than that for mining, especially at 80% carbon. So we're looking probably in European terms closer to 500 or 500 euros a metric ton. And then we use that, and we share in the revenue stream with our joint venture partners, and also with the people that are supplying us the char. We have different structures. We can just buy the char as is, and they can be a supplier, or they can be a significant strategic partner together with us. We prefer that, because then what that does, it allows our strategic partners to be able to do the right thing and meet the 17 Sustainable Development Goals of the UN, which we feel is really critical in this time and day and age.